Hi, I'm Rich with insideHPC. We're here at SC17 in Denver, and today I'm with the UCF Consortium. We have Jeff from LANL, we have Pavel from ARM, and of course Gilad Shainer from Mellanox. And I'm sure there's other vendors as well in this. But why don't we start at the beginning, Jeff? You're the chairman of this, I believe, right?
Yes.
What is the UCF Consortium?
So the UCF Consortium was conceived as this idea for homing or housing open projects. And the first one of those projects is going to be UCX. UCX was originally sort of conceived on this car ride from Los Alamos up to Denver with the idea that we keep recreating this middle space between the programming language and the network hardware. And the intent behind UCX, as we initially conceived it, was to create a clever cut between the network innovation space and the programming model innovation space, so that if programming models were to design to this layer, they would have access to all of the network out there and all of the network capabilities out there. Likewise, if networks were to provide this API, they would immediately support all of those programming models as well.
Okay.
The overall intent was to create something that permitted plenty of innovation space on both sides, and yet at the same time we had this idea that it could eventually almost disappear entirely if it was very well sliced between the two.
Okay, so what was the problem you're trying to solve? Was it every time new machines came, you had to start over? Was it like something like that?
Exactly.
Yeah,
So somebody would invent a new network, and they would have to build an entire MPI stack on top of it.
Right.
Somebody would want to create a new programming model. They would have to code all the way down to the network. And it ended up being a lot of extra work or recreation of effort every time you wanted to bring in a new network or a new programming model. Yeah. And the barrier to entry that created was enough that it was shutting out a lot of innovation in that space. By defining that barrier between the two, we're hoping that we reduce that overall barrier to entry.
Gotcha. Well, Pavel, I have a question for you on development status. Where is this at now with UCF?
Well, most recently we released version 1.2 of OpenUCX, which includes support for multiple architectures. It runs on x86, runs on Power, runs on ARM. Has support for multiple interconnect technologies, obviously includes InfiniBand, support for various shared memory communication types, support for Gemini and Aries interconnects by Gray. The layer was integrated with multiple MPI implementations. We have OpenMPI integration and MPICH integration with UCX. We have integration with OpenSHMEM. And we actually have more work going on in open source community, because once you release it out there, you're starting to see people picking up the source code and building their own stuff.
Okay. Well, Gilad, I want to ask you about this umbrella organization, this UCF Consortium. UCX is the first project. What comes after that?
So first, UCF, it's a great example of a co-design approach, because it includes multiple users of HPC platforms and multiple vendors. So it's a great collaboration. Los Alamos National Lab, of course, is chairing the consortium, but we have other organizations that are part of it. Oak Ridge, for example, is part of the development, and other users, and we have multiple commercial companies or vendors that are participating in the effort. The second, so we start with UCX as the first project, and as Pavel mentioned, I think is moving very, very nicely forward. We will create specifications for UCX, so that's going to make the life easier for vendors or people that write the programs or the applications to actually use detailed specifications. So we enable future proofing of that interface. In the future, UCF is planning to add more projects into the consortiums. We're looking at projects around RDMA models, projects around deep learning frameworks, and many others.
Okay. Is this a stepping stone to Exascale, guys? Is this, you think, a crucial step?
Yes.
Yeah. Okay.
Yes.
Okay.
One of the things that we discovered through Pavel's early work in this was that it actually takes a fair amount of time to get bits on a wire from the programming model. I think our initial measurements were showing something on the order of 600 nanoseconds
even more.
Just to get those bits on the wire. 670, wasn't it?
It was 800, 700, depends.
Yeah,
on
so very long time.
Mm-hmm.
just to be able to get those first bits on the wire from the time you said, I want to send a message. We were able to drive that down in the first pass down to 70 nanoseconds. I haven't asked Pavel just what his current best is, but that's getting down to the point where it's very difficult to be more efficient. That is very bare bones in terms of very lightweight API to get bits on the wire.
Yeah, and as a massive exascale machine, all that latency adds up, right? When we have
Yes.
hundreds and maybe even thousands of cabinets. Okay, so my audience is largely HPC users. What is the call to action here, guys?
So first, before going to that, UCX is going to be used in the large-scale infrastructures being built now and going to build in the future. So we see more and more adoption on UCX, and we're very excited to see the work that is being done in the consortium is actually being used to drive the systems as in the path to Exascale. We do want to call users and vendors in the HPC arena to come and join the effort of UCX or UCF. There is a room for more help in driving specification. There is a room for the new project that we want to drive within the organization. And everyone that wants to join, we're going to welcome him to be part of our effort.
So Pavel, I couldn't let you guys go without asking about future plans. What do you got going?
Well, the project is very active these days. Just for example, in last month, we had over 3,000 contributed code lines from various developers. For the next release, we are really excited. We have some big features coming in. We have support for multiple GPU technologies, support for NVIDIA GPUs and AMD, which means you will be able to communicate across GPUs and additional CPUs. We also adding support for Java API, which means we go beyond classical HPC software. Right now, it will be open for big data community, analytics, and so on.